Okay, here we go with Intro to Logarithms. The two types of logs that you can use in your calculator are log x, which is a base 10 system, also known as a common log. We also have a natural log of x, ln x. It's in a base e system, and again, we call this a natural log. It's used predominantly when you have a base of e. All other logs need to be converted to the base 10 system in order to do the calculations. Here we have a log to base b, x is equal to a. The b stands for the base of the base system that we're using the log in. The a will be an exponent when we convert it to exponential form. And how we do this and how we can convert this over is we take our base b and raise it to the a power, and that b to the a, and that's going to give us equals x. Notice the circular pattern. You have b to the a, and then equals. So b to the a is equal to x. This is the same problem written in what's called exponential form. So that's how you convert from a log to exponential form. Again, log form, the box that's purple, exponential form. They are equal to the exact same thing, they're just written in different forms. Similar to, you can divide by 2 or multiply by a half. It equals the same value, it just is written in a different form. So let's look at this example. This is a log base 3, 81 is equal to x. So we're going to say 3 to the x power. So we're taking our 3 to the x power, and that's going to equal 81. Now, using our knowledge from when we solved exponentials, you would have 3 to the x power equals 3 to the 4th, and therefore x is equal to 4. We can also use logs to solve problems. For instance, if we have 5 to the x equals 25, we can say log base 5, 25, is equal to x. We've changed our exponential form to log form. Notice the base is in yellow. Underlined in yellow is 5. X is your solution, and 25. So we have 5 to the x is equal to 25. Now we're going to look at some properties of logs. The first property we're going to have is log xy. When we multiply two logs together, we're going to make them equal to the same as if we took the log of x plus the log of y. So when we multiply the log of a value, we get the log of x plus the log of y. In the same manner, when we divide, we're going to subtract log of x minus log of y. Finally, the third property we need to know of is if we have log a to the b power, using a log, we're allowed to bring the exponent to the front. This is a great property and is used quite often to solve equations. So these are the three properties you should definitely know how to use. So let's look at this example. We have log 15. That could be divided up into log 3 plus log of 5. And if we have log of x divided by 4, that's the same as having log of x minus log of 4. Finally, look an example of our third property. If we have log of x to the 5th, we can bring that 5 to the front and have 5 log x. So those are three examples of the properties we did in the previous slide. Now we spoke earlier about the fact that only log and natural log are on the calculator, so we must use something called the change of base formula in order to do logs with a different base than the common log or log base e. The formula says that, for example, if you have log 17, log base 3 of 17, in order to put that in the calculator and get your value, you're going to take the log of 17 divided by the log of the base. So you're going to take the log of the number divided by the log of the base of the number, which is equal to approximately 2.579. And these are some laws of logs. The log base a of 1 is equal to 0. And that makes sense because a to the 0 power is equal to 1. So any number that a could be, like 6 or 7, anything number to the 0 power is always equal to 1. Another property here is log base a is equal to 1. That's because a to the 1 power is equal to a. This will allow us later on to be able to cancel out this property and put 1 in its place. It's very important when we're solving equations to be able to do this. And it's always important that you remember that you can't take the log of a negative number or 0. It has to be greater than 0 . So let's look at our log here. We're going to do an example and we're going to expand it out. Notice we're going to bring our 3 in the front and we're going to have log base 4 a, and because it's a multiplication we're going to have a plus sign, and then we bring down our other exponent of 5 and then we put log base 4 b. Here's another example we can use for expansion. Notice the a divided by the b to the third, and then the whole thing is squared. That means a is actually to the 2nd power and b is to the 6th, because we are going to multiply our exponents together. So what we get next is 2 log a, the minus, because it's a division, 6 log b. And that's an example of how to, a couple of examples of how to expand. Now let's look at an example of condensing logs. Notice we have log base 3x plus 4 log base 3y minus 2 log z. If you remember correctly, the plus sign here is indicating that we're going to multiply, and the minus sign here indicates we're going to divide. So we start off with just 1 log because we're condensing all 3 logs into 1 log. And then we start with the very first term. It would be x, then times y, and then remember that 4 comes up and becomes an exponent, divided by z, and then the 2 comes up and is also an exponent. This is an example of condensing. Okay, so that's your introduction to logs. It's a little lengthy, but that should get you through the first 2 pages. And you can also use this as a review for your test at the end of the unit.